Okay, so there are lots and lots of things they can ask you about this method. Okay, and they're they love asking questions about this method, because otherwise the only thing they can ask you is what pretty colour matches to which thing. So they're going to go to town on this method in the exams. Okay, so you need your flame to be non-luminous, and that is the key phrase they like to use. So a non-luminous flame, so not the yellow flame, basically. So you do not want that kind of colour flame, because it will mess up all of your colours. The yellowness will mix in with the colour and you won't be able to tell what colour you've actually got. So you always use what we would call the blue flame or the non-luminous flame. So not roaring, not completely open, but half open, so there's no colour in that. So it should, that's what you're looking for. Best way of phrasing it, a luminous flame would give colour contamination. A luminous flame would give colour contamination because you've got the yellowness. So you will always have it kind of half open, like this, so you could pretty much not see it. The other way people tend to contaminate without meaning to, this is a nichrome wire. Okay, so this is made of nickel and a mixture of nickel and chrome. There's a bit of wire here at the end because it's pretty unreactive. It won't react with any of our solids, and that's what you put your chemical onto to stick into the flame. Now, the problem is, if it's in the flame too long, what is it doing to my flame now?
Contaminating.
Turning it orange. So you can only see the initial colour, okay? Because if I leave it in there too long, everything will look orange. Because both hydrogen and chlorine don't give a colour. Okay, so...
What is that wire thing called?
Nichrome. It is written on there. Nichrome. It's made from nickel and chrome. So the hydrochloric acid, as you can see, guys, does not give a colour. Okay, I can stick it in the flame, no colour, until it starts glowing. So you will always clean your wire because you don't want contamination, and that's kind of the phrase that you want to keep using here. You're trying to avoid contamination. And you don't leave it in there too long, otherwise you get bright orangeness. Okay. We will use our solids. So we'll start with lithium, that's the first one. The best way to get your lithium solid to stick to your nichrome wire is dunk the nichrome wire in the hydrochloric acid so it's damp, and then the solid will stick to it. Right, can someone grab the lights? Because this always works better in the dark. Okay, so lithium first, guys. So can you see that pretty bright red? Reddy purple. Everyone see it? Now, if you're smart, guys, the best way to do this is to hold the wire to the edge of the flame, because then you get less of the orangeness. Can everyone see the pretty red? We call it crimson red. Okay, so you would say lithium gives a beautiful crimson red. It is right. Oh. So the readiness is the lithium. Sometimes you will see orange every time. Anyone want to guess why? Contamination, yeah. The thing that gives an orange flame will turn, it contaminates lots and lots of things. It's very, 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 very common. So we get some contamination. But that bright red, that's your lithium. Okay, still got some lithium on my wire. Oh, can everyone see the pretty green flashes going through it? That pretty greenness, that would be the nickel in the nichrome wire. Burning off a little bit. Straighten the wire back out a bit. Yay. We're almost entirely got rid of the red. A little bit there. Flame colours. Let's go for sodium chloride. Yeah, bright yellow orange. This is our contaminant, guys. Sodium is in everything. It also gives you the beautiful, so we can call this yellow orange. So it's not the same orange as when the wire is completely hot, it's a bit yellower, but it is a yellow orange. Different spot. Yeah, you don't get much contamination with the sodium. Beautiful yellow orange. What's our next one? Really, really, really likes to replace potassium. So when you do your test for this module, which is a practical test where you're going to do flame tests and identify cations and anions, this is the one most people write down as sodium by mistake, because the potassium is one of the harder ones to spot. So let's check our wire is nice and clean. A little bit of green, so that's the nichrome. So can you see this orange is a little bit darker than the sodium orange?
Yeah.
Yeah, it's not as yellowy, so you can tell the difference. Potassium, it's a little bit trickier. And it's usually really tricky to see it. It's really hard to see it. Now the colour, the words they use for it is lilac. So it's meant to be a very pale pinky purple. So they call it a lilac flame. Okay, so you might just be able to see it is a kind of pinky purpley colour, yeah? That kind of pinky purple. Before it goes orange is your potassium. This is actually a pretty clean piece of potassium salt. The technician's done pretty well here, it's not too orangey. So that pretty pinky colour right at the beginning, that lilac, is our flame. Way to differentiate between sodium, lithium and potassium. The remaining ones, calcium and copper, you can do tests with, and copper we will definitely do a test with. I've also bought barium, because barium does another pretty colour and it's always worth looking at the pretty colour that barium goes. I figured we all like pretty colours, right? So, let's pull this one out. Let's do calcium next. Now calcium is the one where people sometimes forget to write the beginning of the colour. So this is calcium. Right. So is it red or is it orange?
Red orange.
So you're not allowed to say red orange, bizarrely. So it's obviously not as red as the lithium. The lithium is like that pinky red, it's properly red, and it's not yellow orange like the sodium. So they call calcium brick red, because its bricks are orangey, and so we call this one brick red. Barium in the solubility lesson. Anyone remember what's special about barium?
Oh, isn't it for hydroxide?
Not hydroxides, close though.
Carbonates.
Not carbonates. Come on, how many are left?
Sulfate?
Sulfates, yeah. Barium sulfate is one of the exceptions that isn't soluble, and that's why we use barium. So, barium, like I said, they won't expect you to remember this colour, but it is quite a cool, different colour to have a little look at.
Water purple.
Barium.
Yeah, like Koopa Troopa Baby.
Oh.
It is Koopa Troopa. That's a Slytherin. No. Too high. Are we saying light? Are we saying stuff?
Can you see the brief flash of green?
Yeah. That's I think it's Luigi's Haunted.
So, this one is a very, very pale green, guys, actually. They call it apple green. I assume because it's a yellowy green compared to what we're about to see. So they call barium because it's a cool colour, so they like to include it in the flame test. But you can actually make insoluble copper compounds. Like copper carbonate is insoluble. So you can make copper hydroxide is insoluble. But it does make a pretty colour, so we're going to flame test it as well. And this is the last colour that you will have to memorise, guys. Nearly done.
I'm saying it goes like 4 black.
Still got a little bit of barium on this one.
It's green. Nah, it'll be like gamma rays and all that.
Nearly there.
1 hour for
Yes. Green lantern, green.
Go for copper.
Oh, that sounds blue.
It looks like the northern lights.
So
It's the northern
the
lights.
blue, guys, is actually the nickel. The copper is the green around it.
That's Luigi green.
So
It's
that's
northern light green.
that's what we call straight up green. This is not the apple green. It is just really green. Yeah, the blue is actually nickel is less reactive than copper, so the copper is displacing some of the nickel in the wire. So this wire is now completely useless, but it does make a very pretty green flame.
Standard.
So the blue is actually the nickel, the green is actually the
The
copper.
northern lights.
That feels the most like the Northern Lights, doesn't it? I'm wondering if it will put some through the bottom. Nah, it won't. So what you can do, guys, and I like doing this is why I like doing this as a demo, because you can do this, is if you're a little bit naughty, you make fireworks. And if you've ever wondered, this is how they make fireworks. They dose it with different coloured salts to get the pretty colours.
I know you do.
Do you know what the gold sparks are in fireworks?
Sparks.
What do they use to make it?
Plasma.
Nope. It's iron. If you get iron filings and burn them, you get pretty orange gold sparks. So most fireworks are, if you've got something that's green with gold sparks, it's got a mixture of copper and iron in it.
Stop water.
Approximately how many grams would it take to like make a like
Not very much actually. It's pretty low. Yeah, you don't actually, because fireworks of course are even hotter than this, you get that instant excitation. So you don't actually need much more than we're using here. Okay, barium's the poisonous one. Yeah, barium's poisonous. I'm looking at it. Yeah. Barium not for barium not fun. Okay, let's see if we can get a little bit of a. So we should.
Northern lights.
So did you get the different ones?
Airplane.
As you may be able to spot, guys, copper is definitely something that burns the brightest. We've got some nice pretty orange and reds. Okay. Now guys, your job is to fill in the questions at the bottom.